So in this lesson, we're going to be looking at special products again. So remember how we had the difference pattern and then we had that perfect square? We can basically do the same thing, but now work backwards to get the factor. So again, remember we're getting the product and we want to break it down into the original multiplication problem. So in the video, we're going to look at what's called a difference of two squares and how that goes back to that sum and difference pattern. So you need two values again. So A and B are really important, and it's always going to be subtraction. In the problem. And when we see that happening, if we can get perfect squares for A and B, right, A squared, B squared, then we get the pattern A plus B and A minus B. So what we basically want to do is rewrite your problem as something squared minus something else squared. So in A squared is x squared, and B squared, remember, ignore the negative sign, it's 64. So what we want to do is we want to figure out what A is and what B squared, what B is. So remember, the inverse of a square is a square root. So what I'm going to do is I'm basically going to square root both sides right here to figure out what A and B actually are. So A here is going to be x and B is 8. So we only take the positive radical, the positive root, excuse me, for this pattern. So we can rewrite x squared minus 64 as x to the second power minus 8 to the second power. Make sense? So then our final answer, we're going to go with this pattern. It's A plus B, A minus B. So this is going to be x plus 8 times x minus 8. And you can always multiply to check. So multiply to check. I know I'm not going to do that in the video to make the video longer, but I definitely recommend it, especially if you are using shortcuts, because a lot of times we use a shortcut, we get up straight to it, and we may not realize when we have the wrong shortcut. So by taking that extra time to check, you can see, oh, did I do the right work or not? Okay? Alternatively, if you don't remember this shortcut, you can always go back to the factoring by grouping and the trinomial. So let me write that down here as a quick note. So you can always make a trinomial by adding in the missing term. So you see how we have x squared but no x, and then we have the constant? You can go x squared plus add in a 0, because 0 represents nothing, right? So we can do x squared plus 0x minus 64. Oops, move that on accident. Minus 64. And then you can go ahead and do that puzzle with negative 64 x squared on top, 0x on the bottom, and see this would become negative 8x and positive 8x, and then you could keep going. So remember, it's great to know these great to know these shortcuts, this difference of two squares pattern, but if you don't know it, you can always power through it using your puzzle. Okay, so if we take a look at B, hopefully you'll see why knowing these shortcuts is sometimes a good idea. So let me separate A and B. So the shortcuts, like I was saying earlier in the lesson when we were looking at the products, is nice when you have large numbers. So if you actually wanted to do the puzzle here, you'd make this 25b squared plus 0b minus 36. And then you'd have to go back and think, oh gosh, what is 25b squared times negative 36? And do some large digit multiplication, which some of us may not want to do. If you want to, more power to you, go for it. And you can always, guess and check and make that puzzle work. However, if we recognize the pattern and say, well, hey, a squared is equal to 25b squared. The b squared in the problem is 36. This is a subtraction, so this is set up for the difference of two squares pattern. So all I have to do is just square root everything right here, and then that's going to give me, oops, let me square root a squared and b squared as well. A equals 5b and b equals 6. Again, we only want the positive roots. because we're really just thinking about what the positive value of that would be for the expression, since this wasn't an equation to begin with. Okay, so I'm going to go ahead and then use my a and my b in the pattern. So the answer is simply 5b plus 6 and 5b minus 6. Again, a plus b, a minus b. All right. Again, multiply to double check just to be sure, because you can never, be too careful, and then make sure you have the correct product. So I'll check this one really fast. Using whatever method you want, foil, box, anything you want. I'm going to FOIL this. So I get 25b squared minus 30b plus 30b minus 36. These cancel out to give me 25b squared minus 36, which is what I wanted. All right. So example C is another type of problem where I thought was kind of nice if you had this pattern when you're doing some quick math. If you had a piece of scratch paper, if you're not allowed to use a calculator, for example, how can you do this really quickly? Well, we have a special product pattern. So if we recognize 68 squared minus 62 goes with that a squared minus b squared equals a minus b times a plus b. All we have to do is recognize a and b, and then we can do the multiplication. So here, hopefully it's pretty simple. To get a, you just get rid of the exponent. So a is just 68. And b, same thing. We don't really care about 62 squared. We just want the base of that. And then I can plug it in. So this becomes 68 minus 62. And then 68 plus 62. Being very careful, a needs to go in front. A is the positive, right? And b is the negative, what comes after the minus sign. And then I can do this really quickly on pencil paper, right? Or in my head even. 68 minus 62 is 6. 68 plus 62 is 130. Multiplying that, I get 740. Oh no, sorry, 780. Okay. So I'm going to have you guys try 1 through 5 for me, and then we'll come back and double check your work. All right, go ahead and double check your answers. So I've boxed all of them, and I also wrote down the values for A and B if you wanted to double check your shortcuts. Remember, if in the end, if you don't remember these shortcuts, that's okay. It just kind of helps when you have numbers that are large, like number 3, right here, right? So instead of having to do 16h squared times negative 49 to get your puzzle, we can just go straight into square roots, which I know a lot of us are usually pretty good with, at least, up to 10 or 12. All right, we'll finish this off in class. Thank you for listening. Come back with questions.